Hello, my name is Alejandra Crespo. I study electromechanical engineering. My topic is about graphene solar thermal thing could be a new way to harvest renewable energy. Definition: a noble energy efficient metamaterial can efficiently absorb sunlight while limiting black body heat loss to almost zero. Research at the Center for Translational Auto Materials (CTAM) and Sembor University of Technology in Melbourne, Australia, have developed a new graphene-based film that can absorb sunlight with an efficiency of over 90% while simultaneously eliminating most IR thermal emission loss. And we have a video about a potential source of clean metals energy.
So graphene is a single atomic plane of graphite. We've been studying a lot of different properties of graphene. And at one point we decided to make it freestanding. We figured out what was happening is the membrane is kind of shaking around. The atoms are shaking around and vibrating, but then every now and then this local, let's say convex section of the membrane would flip its curvature over and become concave. If we place a charge on that ripple and it moves suddenly near a grounded conducting electrode, charge will flow in that conducting electrode basically to screen the charge that's moving toward it. If we had another electrode above it, when it flipped back, then the charge would flow, say in a circuit, up to this thing here. And the size of the samples that we look at are 10 microns by 10 microns, which is pretty small because about 20,000 of those could fit on the head of a pin. But one of these 10 micron by 10 micron areas could produce 10 microwatts of power continuously. So wouldn't that be great if you had this, powering your watch, for example? You would never have to replace the batteries. I like to think about the possibility of anyhow. Some people have, let's say, pacemakers or mechanical devices as bioimplants. And if you could have a power source that you didn't have to replace the battery for, it's basically a battery alternative. I guess that's the key thing. If you could have a battery alternative that you didn't have to go and replace it, imagine, all the things you could do.
Applications in electromechanical results. The result is a fission solar hairy metamaterial that can heat up rapidly to 83 degrees C and 181 degrees F. In an open environment with minimal heat loss, the graphene film is designed to absorb light between 0.28 to 2.5 micrometer wavelength, and the copper substrate is structured so that it can act as a selective bandpass filter that suppresses the normal emission of internally generated black body energy. Applications: for energy harvesting and storage, thermal electricity generation, and seawater desalination.
In 2004, two Russian scientists used Scotch tape and a graphite rock to discover graphene, a layer of atoms arranged in a honeycomb structure. Thanks to this discovery, the world was introduced to a groundbreaking material that can change our world. Here's why. Graphene is the thinnest known material, only one atom thick. It would take 3 million sheets of it to equal the width of a pencil tip. Despite being the lightest known material, it's also the strongest, harder than diamond, and 200 times stronger than steel. It can bend, is almost entirely transparent, conducts electricity and heat better than any other material, and allows nothing to pass through it except water. So how can the unique qualities of graphene help the world we live in? Imagine flexible cell phones, a TV thin as wallpaper that you could roll up and take with you, stronger but lighter aircraft that uses less fuel, standard-sized batteries that hold a longer charge, smaller computer chips leading to faster electronics. With its superconductivity, graphene could play a huge part in the future of solar power and in revolutionizing electric cars by enhancing their batteries, making them more efficient and eventually more affordable. Also, graphene is proven to be an anti-corrosion coating for metal that is transparent, thinner, and longer lasting than anything that currently exists. But its most important use may be in the future of clean drinking water. Graphene's ability to let nothing pass through it except water makes it the world's greatest filter. Graphene could cheaply and easily remove salt from seawater, potentially turning the oceans into a vast drinking supply for thirsty populations. With this wonder material getting so much attention from scientists and researchers worldwide, it may not be long before graphene-equipped products find their way into stores near you.
We demonstrate a 90 nanometers graphene head absorbing material. Our new two-layer structure is simpler and doesn't require vacuum deposition, and the method of fabrication is scalable and low cost. With I present an other video about the mild graphite solar phone, the future of thermal power generation.
Hey guys, Nick here, and MIT is reporting that it has created a new, incredibly cheap material that converts sunlight into steam with an amazing 85% efficiency rate. Technology like this could have major repercussions in regards to desalination, sterilization, and solar thermal power generation. The new material consists of a thin double-layered disc. The bottom is a spongy carbon foam that doubles as a flotation device and thermal insulator. The foam prevents any of the solar energy captured from dissipating into the fluid underneath. The top layer consists of flakes and graphite that were exfoliated using a microwave. The microwave causes the graphite to bubble up almost like popcorn. Now, when the sunlight hits the graphite, hot spots are created where water is drawn up through the foam via capillary action. The hot spots are hot enough to turn the water into steam. The efficiency percentage comes from the amount of incoming light, a solar intensity of 10 times that of a typical sunny day, which is easy to achieve with a simple lens or reflector. 85% of incoming solar energy is converted to steam, assuming that liquid water is readily available. And then there's what this spongy steam maker can actually be used for. Bulk desalination or sterilization, sure, but what about power generation? Current thermal power plants use Fresnel lenses that concentrate sunlight by up to 1,000 times. If steam can be produced with just a tenth of that, system costs and efficiency can both benefit. But clearly a lot more work needs to be done before this stuff revolutionizes power generation. It's clearly early days, but problems like limescale corrosion have been around forever. But on the upside, there also exist tons of ways to combat it. If MIT really has stumbled across a way of cheaply and easily producing steam from sunlight, then this could be big news, so I'll keep you updated. And as always, thanks for watching, and I'll see you guys next time.
Pros and cons. Pros. Finding a manufacturing method for making this extract scalable. Fine-tune the nanostructure design and improve on the SGMS stability and absorption efficient. Cons. Fabricating a new trend nanostructure method of fabrication is scalable and low cost. Use less graphene, transferring the absorbed heat more efficiently to other media such as water, helping to extend the material's lifetime. I present you about a video in that experiment with the graphene.
This is a solar cell using graphene nanoflakes. By using graphene nanoflakes in the solar cell, solar power can be converted directly into electricity, and the setup itself combines the battery and the solar cell in the same unit. One electrode of copper and one electrode of aluminum is placed in water with graphene nanoflakes. The large parabolic sun dish focuses sunlight into the battery and creates more power than just being in ambient sunlight. This is the current measurement on the cell, measuring the current flowing. This is the voltage. The multimeter has now been set to voltage and is reading the current voltage of the cell. Graphene nanoflakes can be made by either the University of Kansas's method using acetylene, oxygen, and a spark gap detonator, or the Petric method, which uses exothermic reactions on coal.
Applied in Ecuador. We have energy harvesting and conservation applications, steam generation, wastewater cleaning, seawater desalination, and thermoelectricity generation. The graphene industry is approaching a tipping point.
The graphene industry is approaching a tipping point, and commercial success is just around the corner. We at ID Tech X view that the current market is in the order of tens of millions for graphene manufacturers, and we forecast this will rise to over 300 million within the next decade. Now, despite this, there are still a huge number of challenges to overcome as players start to scale up, as these costs start to come down, and as industries start to find applications where graphene and other 2D materials can add value to their applications. There are two main approaches to graphene manufacturing. There's a top-down manufacturing process where you take graphite and usually through an exfoliation or some kind of oxidation reduction process, form powders and nanoplatelets. And these have started to find notable applications in the likes of energy storage, in thermal management for smartphones and automotive, and in mechanical properties, from everything from elastomer liners through to polymer pipelines. Then there's the bottom-up approach, often using a CVD process. These are forming monolayer or few-layer graphene films, usually in large sheets or in wafers. And these have started to gain traction in optoelectronics or other sensing devices, and it's another key emerging area that we're seeing. To hear more about the future of graphene commercialization, join us on May the 13th to 14th in Berlin for Graphene and 2D Materials Europe. This two-day conference brings the graphene community together. You hear from graphene manufacturers and their partners, through to integrators and the end-user perspective, really to give you a complete overview of the graphene industry. We'll have many applications on display on our trade floor, and we'll hear some really groundbreaking news. This two-day conference is co-located with many key verticals for the graphene sector, including sensors, printed electronics, electric vehicle materials, and more. So join us on May the 13th and 14th to find out about the home of graphene commercialization.
And finally, we have a conclusion. The new material also uses less graphene by significantly reducing the film thickness to 1/3 and its thickness aids in transferring the absorbed heat. Are not looking for is a suitable method for large-scale production of the copper substrate. When I thank for your attention. Bye.